All right, today I would like to talk about the features of a quadratic function using a context. So for my example, we're just going to look at a height of a ball thrown in the air. We're going to use feet for height, over time, and our time's going to be in seconds, and we're going to model that in this graph. Okay, so the ball is thrown starting at 0 seconds, and then we're going to see what happens. So we're going to use this context to talk about all the different features of the functions, thinking about our units as we go. So before we dive into looking at all of the features, let's just make sure we understand what's happening in our picture or our graph. Okay. First of all, we know that our time is going to be our x-axis, and we know the unit for that is going to be in seconds. Then we know we're measuring the height of our ball, and that is going to be our y-axis. And our height is going to be measured in feet. So any ordered pair on our graph, x comma y, can be interpreted as time comma height. And if we're thinking about units, it's going to be seconds comma feet. Okay. When you're looking at this graph, you will see a shape of an entire parabola. But because our problem is in context, we really need to look specifically at what domain and what range represents the context of our problem. So because we are looking at throwing a ball, okay, the ball is going to start being thrown at 0 seconds. And when we throw the ball, it's going to go up, then it's going to come back down, and then eventually what's going to happen, as long as there's no holes in the ground, the ball's going to hit the ground. Okay? So the first two things that we ask you to consider is what is the domain and what is the range of our problem in context. So if you remember, the range refers to the possible y values. So if you look at my graph and what I highlighted in green, which y values are being used in our graph? So you will notice that the y values being used start at 0 and go all the way up to right about here, which has a y value of 22.4. So my y values start at 0 and go all the way up to 22.4. That is my range. So what does that mean? It means that the height of the ball is between 0 and 22.4 feet above the ground. So while it's being thrown at any point in time, it's between 0 and 22.4 feet. Okay, now the domain are the possible x values. So again, thinking about the context of the problem, the domain is going to start at 0, x values is time, at 0 seconds, all the way to the point where that ball hits the ground. And in that case, that's going to be right at that x-intercept with an x value of 15.4. So my domain is going to start at 0 seconds and end at 15.4 seconds. So interpreting what that means, the ball is in the air between 0 and 15.7 seconds. And when you're providing your description of what these intervals mean in context, you want to make sure to include your units. Okay. The next thing we can talk about with interval notation is when the ball is either increasing or decreasing. So for this particular problem, we're asking, what is the interval where the graph is increasing? Okay, so let's look at this. So we start right here at 0, 5.13, and that ball is being thrown up, and then it reaches a turning point, and then it starts to go down. So the ball is increasing, and then it shifts, and it starts decreasing. So we are asking, when is it increasing? When you look at this, you're looking at, for what x values is the ball increasing? So it's increasing starting at the x, it keeps increasing, and it stops increasing right here when the x value is 7.2. So we would say from 0 to 7.2 is when our ball is increasing. Then I'm just going to write that interpretation. The ball is increasing in height from 0 to 7.2 seconds. Okay. All right, we've already talked about this very important next number, which is the x-intercept. Remember, the x-intercept is where our graph crosses the x-axis. So that is occurring on our graph right here at 15.4, 0. Remember that x-intercept should be a point or an ordered pair. Now, in the context of the problem, what does that mean? So remember, we talked about the ball is being thrown up in the air, starts to come down, and then it lands on the ground. So that is what that x-intercept means. It's the time when that ball hits the ground. But more specifically, it's the time when the ball hits the ground. Remember, our ordered pair is time, height. So the time, 15.4 seconds, when the height is 0. So let's write that out. I'm going to say at 15.4 seconds, the height of the ball is 0. So you could say that, or you could say the ball has hit the ground. All right. All right. The next thing we're looking at is, what is the maximum value of the graph? And for that, we'll go back to looking at, where is that turning point occurring? So we had said, I'm just going to erase some of my markings. Bear with me. We had said that the ball is thrown, it's increasing, and then it starts to decrease. So that occurs at this turning point right here. All right. And we would call this turning point a maximum. Another word for this turning point would be the vertex. So our vertex is a maximum. And our question here is saying, what is the maximum value? And remember, when we're looking for our maximum value, we're looking at what is that output, or the y value. Okay, so the highest that this ball goes is going to be the y value, 22.4. So what does that mean? It means that our ball reaches a maximum height of 22.4 feet before it starts falling to the ground. So the ball reaches a maximum height of 22.4 feet. And finally, the last thing we're asking for here is the y-intercept. Remember, the y-intercept is where our graph crosses the y-axis. So right here. So that is a point on our graph, so it's going to be at 0, 5.113. Okay, remember the y-intercept is an ordered pair. So thinking about the context of our problem, what does this y-intercept mean? Well, time, height. So this is saying when our time is 0, our height is 5.113. So we could think of that as the initial time, or I'm sorry, the initial height. All right, so if I'm putting that into words, at 0 seconds, the height is 5.113 feet. You could also say the initial height is 5.113 feet, or the height before the ball was thrown is 5.113 feet. All right, there's one more thing I want to point out. I kind of skipped over it, but I think it's important. When we were talking about x-intercepts, and we said our x-intercept was 15.4, 0, I wanted to point out that there also is another x-intercept right here. But the reason that I did not include that x-intercept is because we were talking about the x-intercepts in the context of the problem. And this x-intercept would have a negative x value, which would mean time would be negative. And we know that that is not in our domain of our problem in context. So that is why we did not include that in our answer. Thank you.